everyone, this is me Shishir and you are watching GATE Academy Global, and this is the syllabus of electronic devices. One of the topic that includes in GATE 21 electronic devices, that is MOSFET, and we are on the lecture 3 of this MOSFET crash course series, and the name of this series is MOSTOK, and we are transferring the knowledge of MOSFET to the students so that the student will get benefited while writing the examination in 3 hours duration of GATE. So this is a exclusive crash course running by GATE Academy. So we have designed the MOSFET. We understood that what is our intention to design the MOSFET. We just need a dependent current source, and in which particular parameter the current should depend. It should depend on voltage. And we understood from the previous 2 lectures that we need to design a layering structure, and layers means the ground layer is nothing but the substrate. We just write here, this is the substrate, and this substrate is also called bulk or body. Okay, and this is one semiconductor, and we are taking our favorite semiconductor in MOSFET, that is the p-type semiconductor. And the second layer is nothing but the silicon dioxide layer, and the first one, the layered structure, the first one is metal. So it is called metal oxide semiconductor. We understood that there must be an electric field which is present in the vertical direction, which is directed from the metal towards the semiconductor in this direction. Okay, in this direction, in this direction, in this direction. And this particular metal is having equipotential surface. Equipotential surface means at each and every points on the metal, we are having the same potential if we apply some external potential at the gate terminal. So that means whenever we are applying, whenever we are applying a potential at the gate terminal, it will give rise to an electric field which is directed in this direction from the metal to the semiconductor. This is the direction of electric field, and of course we are having the positive charges. If we are applying a positive voltage at the gate terminal, we are having the positive charges on this metal like this, and the equal number of negative charges on the semiconductor side, and that negative charges are nothing but the electrons. So this is the layer of electrons which can be present on the surface, top surface of the semiconductor. And because of this positive and negative, we are having the presence of electric field in these 3 layers, that is metal, oxide and semiconductor. And that will give rise to an electric field. And in addition to this electric field, we have seen that there must exist a capacitor, because we are watching here that we are having the top plates which is acting as a metal plate, and this will be like this, and the bottom plate that is acting as a semiconductor, that is nothing but consisting of more number of electrons. And these are the 2 plates of the capacitor, and we know the capacitor is a passive element. Until unless we are applying some external potential to this capacitor, we doesn't have any potential difference between the 2 plates of the capacitor. So we must have to apply an external potential, and in between these 2 we are having definitely we are having a material that is acting as a dielectric. We can watch this dielectric which is present in green color in between this metal and semiconductor, that is nothing but silicon dioxide in metal oxide semiconductor. And when we apply a potential, this is the external potential, it is not now in equilibrium. So initially it was in equilibrium, this must be neutral. This is plate 1 which is neutral initially, this is plate 2 which is neutral initially. But after the application of this voltage, if I name this voltage gate voltage like this, so then what are the 2 points here? These 2 points are nothing but the gate terminal, and we are calling this one is body terminal. So whatever potential that we are applying here, always that potential is applied between gate and body. So what is the potential? What is the potential that is applied at the gate? It is always positive. So it should be at less potential. So if it is less potential, then I can connect this body terminal with the ground potential. Okay. So there is first potential that we have applied at the gate terminal. That is nothing but the gate potential, and this potential must be a positive value if the substrate is of p-type. So when we are having substrate and the substrate is of p-type, then we can say that for making a conductive path of electrons, we have to apply a positive voltage at the gate terminal. So what is the main reason for applying the gate terminal potential positive to construct an inversion layer? So we want to construct an inversion layer. What we want to construct? We want to construct an inversion layer. So what is there? This inversion layer is present. It is a p-type semiconductor, and this layer is known as the inversion layer. This layer is known as the inversion layer. So this particular layer is also called what? This particular layer is also called the channel. So meaning of this channel is nothing but the presence of a very highly conductive path between source and drain. So when we are taking this is a p-type semiconductor, it is mandatory to take this is n plus region highly doped, and this is n plus region highly doped. The reason of taking this heavily doped region, I already said in my previous lecture that we just want to maintain a ohmic contact between the metal and the semiconductor, so that there must be a two-way direction of current without any rectification. So there is each and every point that must be important here. So whenever we are applying a potential here, we are having a positive charges that can be present on the top side, and we are having negative charges seen on the bottom side. This is nothing but metal, and this is oxide, and this is semiconductor. So metal oxide semiconductor always need to create an inversion layer. So we need to apply a voltage, and that voltage, if you consider, then the voltage is a positive voltage, and in addition it must be greater than threshold voltage. In yesterday's class, I give you the description that why we need a constant amount of voltage to create an inversion layer, because it will give rise to breakdown of the charges present within the semiconductor, and by breakdowning the charges we can create a inversion layer within the semiconductor surface, and that inversion layer must be used to flow off the current. So this is the first voltage that we have to apply, and I think that you understood that what we need to construct here. So we have a question right now here: which action plays a significant role in enhancing conductivity of channel by inducing the free electrons, especially in enhancement mode of n-channel MOSFET? So we are going to take a particular mode of operation from this particular question, which is an MSQ question, because this series named MSQ and quizzes, and we have to take MSQ and quizzes to give you better understanding behind the sequence of steps that is occurring inside the MOSFET. So I want to tell you certain points. The first point is, first of all, whenever we are watching a MOSFET or we are taking a MOSFET and we want to analyze the MOSFET, the first thing is that you must observe which type of substrate we are taking. So this substrate is very important to understand that whether we are working in PMOS or NMOS. So if the substrate is of p-type, then semiconductor, then we are working on which MOS? Then we are working on NMOS, because we are creating a channel which is of electrons. That's why it is called NMOS. If the substrate is of n-type substrate, then we must observe that we always work a case that is known as PMOS. So these are the two types of MOS that is very important to understand. And the second thing that we have to understood that in NMOS we are having only one type of charge carriers that will help for the conduction of current. So sir, I can't see any conduction of current here. I want to see the conduction of current, and I want to solve this question also. So we have observed that if you are talking about which action plays a significant role in enhancing the conductivity? Enhancing means increasing. So if you want to increase the conductivity, then we have to apply some voltage. I just told you that if you want to increase the conductivity can only be increased in case of MOS by applying some voltage. That's why we are understanding the behavior of dependent current source. So if you are increasing the conductivity by doping of this p-type semiconductor, then the current is not depending on voltage. In that case, the current is depending on doping, and we cannot able to construct a amplifier by using this MOSFET. So the work or the main task of this particular gate voltage is to create a conductive channel. So this gate terminal voltage is actually creating a conductive channel. So I just separate this one by a line, and I must write certain points here. So this is the first point, that the gate terminal voltage is positive if the substrate is of p-type. Okay. So anyone can ask, sir, if the substrate is of n-type, then what is the voltage? Then the voltage must be negative. So I will tell you, to construct an inversion layer, the gate voltage must be greater than 0, and this Vg is the reason behind the conductive channel. Vd is the reason behind the conductive channel, So we have seen that to make a conductive path, we have to apply a voltage at the gate terminal, and by using this gate terminal, we just observe me what I am writing here. We just enhance the conductivity of the channel. So it is enhancing the conductivity of the channel. That's why we are calling it, this is working in enhancing mode. So we are writing enhancing mode. Okay, enhancing mode of operation. So why it is called enhancing mode? Enhance means to increase. So we are increasing the conductivity of the channel by applying this gate terminal voltage. So gate terminal voltage is the reason behind inversion layer, and we must apply a gate terminal voltage above a certain value of voltage, and that voltage is known as threshold voltage. And when we apply threshold voltage, gate is the reason behind the conductive path, and it is also terminal is the reason at which if we apply the voltage, then we are working in enhancing mode of operation. So could anyone can ask you, do you have another region or mode of operation? Yes, we have another mode of operation, but you just not confuse yourself with accumulation or depletion, because here there is no meaning of accumulation of depletion if you already studied MOS capacitor. So you just exclude the theory of MOS capacitor from the MOSFET if you want to understand the MOSFET clearly. So we are using certain process that is occurring in the MOSCAP, but if you are watching this English channel and you are continuously watching from the lecture number 1, that till now I haven't given you any description about the MOSCAP if you are following Gate Academy global channel. So when we are talking about all these things, all these points, then we understood that there must be an electric field which is working here, and we must have a capacitor here, and this capacitor will be happy only when we apply. This capacitor is very happy. The reason of the happiness of this capacitor is that we are having equal number of positive and the negative charges. So now come to this question, which action plays the significant role in enhancing the conductivity of channel by inducing the free electrons, especially in enhancement mode of n-channel MOSFET? So there is no inductor action, so we just cut it down. There is no resistive action, we just cut it down. So there must be a capacitive action we have seen now, and we have seen that the electric field formed between metal and semiconductor, which is the reason to enhance the conductivity of the channel. So I just take this one also. So we have to find out the action that is used for enhancing the conductivity of the channel. and we concluded that to enhance the conductivity of the channel, we must have an electric field, and this electric field can be come into existence because of the application of the voltage, that is the gate terminal voltage, and there must be an capacitive actions which is taking place between metal oxide and semiconductor, and because of this capacitive action we are able to create a conductive path between source and drain. Now this thing is over. Now we understood that there must be a substrate. We just have to see the substrate whenever we are understanding as MOSFET, because this substrate will decide the p-type and n-type semiconductors. So the first thing that we understood here, that we must have to see the substrate. Then the second thing we must have to observe is, right now here, is you need to understand that your substrate consists of any channel inbuilt initially, or we are creating the channel. So in the substrate only we have to find out whether the physical channel is available or not. So we just have to find out physically there must be physical channel. So we just write here physical channel is available or not. So I think you won't understood what is the meaning of physical channel, available, or we just have to understand that whether it is not available. So here we can see that it is working in enhancement mode or enhancing mode. That means we apply a gate terminal voltage, and by the application of gate voltage we are creating a channel and we are enhancing the channel. But there is some particular MOSFET which is available physically, in which we need not to create a channel. The channel is already created. That means physically there must be a conductive path present between the source terminal and drain terminal. That type of MOSFET is actually called depletion MOSFET, or that type of MOSFET is also called depletion mode MOSFET. So I mean to say that if we don't have any physical channel between the source and drain, then the MOSFET is called enhancement MOSFET, and if you are having a physical channel between source and drain, then the MOSFET is known as depletion MOSFET. I just need to take this one as a classification of MOSFET. So we just classify the MOSFET. So I just classification of MOSFET. Okay, we just solved one particular questions that is based on creating the channel, and we understood that the MOSFET can be classified into two types, whether we have to create the channel or whether we don't have to create the channel. If we are creating the channel, if we create the channel, if we create channel by applying a gate voltage channel by applying VG. Channel means a conductive path. By applying VG, then we can say that this type of MOSFET is known as enhancement type MOSFET. So we are writing here this type of MOSFET is enhancement type MOSFET. Enhancement type MOSFET. Then second one is we create a channel. The second one is the depletion mode. In depletion mode, we don't apply any gate voltage to create the channel. The channel is already created by fabrication, in fabrication laboratory by the fabricator who has designed the MOSFET. So if you are not getting this point, then I want to see another thing which is present in this particular diagram. So I just take a copy of this diagram so that I can use it again, and I must paste this one in the next slide so that we can use if we require this one, because in MOSFET chapter we generally need this type of MOSFET. So I came again and we just draw. So here is the same MOSFET, and suppose I will tell that this is a p-type substrate, this is a p-type substrate, and we are having this is n plus region, and we are having this is n plus region. And initially during the fabrication process, without applying any gate voltage, I mean to say that this particular terminal is the source terminal, this is gate terminal, this is drain terminal, and without applying any gate voltage, we are not applying any gate voltage, the gate voltage must be 0. And in that case, if physically during fabrication, if we have constructed a conductive path between source and drain like this, between source and drain like this, this is the conductive path between source and drain. So without applying any gate voltage, if already we have a conductive path between source and drain, and this conductive path is made up of same type of material which is required or which is supporting the current conduction in p-type substrate. Who is supporting? Either electrons or holes, because this is a unipolar device. So if this is N plus, this is N plus, by doping or adding certain impurities in this channel, we have created a path, and this path is made up of N, that is the electrons. This path is made up of electrons. Then we can say that this particular type of MOSFET, in which without applying gate voltage, if initially physical channel is available between source and drain, then this type of MOSFET is called depletion type MOSFET. The reason why it is called depletion type MOSFET, we are going to see just after this particular line. So in depletion type MOSFET, if you are writing physical channel is available, I just write here we are not enhancing, the physical channel is available, physical channel is available already, and this is channel means the conductive path, and this is known as the depletion type of MOSFET. This is known as depletion type of. And in gate we are getting both type of questions, either in enhancement type or depletion type, but very low, we can say very less frequency is there for this particular depletion type MOSFET, but more 90 to 95% of the question will be from enhancement type MOSFET. But we won't take any risk, because they are not mentioning that whether we are going to take only enhancement type or depletion type. This is only due to that enhancement type MOSFET is mostly used in practice. That's why we are using enhancement type MOSFET in our analysis of gate questions also. But if we have suddenly a depletion type MOSFET question, then how you can understood? That's why I am giving you how we can form a depletion type MOSFET. So we have constructed a depletion type MOSFET and we have constructed an enhancement type MOSFET. So this type of MOSFET in which we are applying the gate voltage, and because of this one we are getting the electrons concentration by the application of voltage. That means we are enhancing the channel. So then it is called enhancement type MOSFET. And if we are having already a physical channel between source and drain, the conductive path, and we doesn't need to apply any gate voltage to create the conductive path, then that is known as the depletion type MOSFET. So this is the main thing that you have to name when we are working on NMOS or PMOS. But the substrate will decide the type of MOSFET, and the availability of physical channel or not, this will decide the mode of operation of the MOSFET. Either we are working in a depletion type or we are working in enhancement type. So depletion type or enhancement. I think you students has understood enhancement type. Understood. So enhancement type. So if you are talking about depletion type, channel is available already. So I just write here we are having the channel is available, and here we mean to say, here we want to write here the channel is not available. So we just write here channel is not available. So we just have to create a channel. But I want to add a certain point here. What is that point, sir? If you are working in depletion type MOSFET and you just want to make or use this depletion type MOSFET in enhancement mode of operation. Sir, what is the meaning of this one? The meaning of this one can be created by understanding the feeling of this structure. Since we already have an electrons concentration here, and in the MOSFET, the second thing that we have to understood that we have this source terminal should always be grounded in an NMOS, and this body terminal is always be grounded. There are 4 terminals. So I am talking about an NMOS, either it is a depletion type or an enhancement type. We are not care about this one right now. But we need to understand the potentials that are applying at different particular terminals of the MOSFET. So one by one we understood that there are 4 terminals, and if you are talking about NMOS, then we just understood that the source terminal potential Vs should be equal to 0, and we are having the body terminal potential that is equal to 0 in practice, and we are having the gate terminal voltage that is positive, because in cases of enhancement type MOSFET, this gate terminal voltage is positive because in enhancement type we want to create a layer of conductive path on the surface of the semiconductor. That's why we are writing a positive voltage. And if you are writing a positive voltage, then we want to write here the mode of operation is enhancement mode here, and next one is, the last one is nothing but the drain terminal voltage. So how to understand that what is the voltage that is applied at the drain terminal? In an NMOS, we are always applying the drain terminal voltage that must be a positive voltage, because the drain terminal will, the name of this one is drain terminal. The reason is that I can take this demonstration either in depletion type or enhancement type both, because just we are talking about enhancement NMOS, and whenever we have to create the difference between this NMOS depletion type and enhancement type, then we will write. So if I am writing the gate terminal voltage is positive, that means we are working in enhancement mode. But there is no difference here, the source terminal and body terminal. Either it is in enhancement or depletion type MOSFET, we have to make this 2 terminal connected together. They can connect together because both are at same potential. So we have to think about drain terminal voltage. This drain terminal, the voltage that is applied to the drain terminal is always applied to attract the majority charge carriers in the inversion layer towards the drain terminal. So I mean to say that the electrons has to be attracted in this direction, and it should be repelled from the source. This is the main part to decide which voltage that is applied at the drain terminal. So if anyone say that I want to attract the electrons because the channel is made up of the electrons, then I must apply a positive potential at the drain terminal. So I must apply a positive potential at the drain terminal. So drain terminal must be applied with positive potential, because this positive potential will attract the electrons. If the electrons is moving from source to drain, then we can say the direction of current is from the drain to source, because always the convention current is in opposite to the direction of movement of electrons. And if it is the conventional current, then I can write the current must be positive. So in this diagram, you can have the idea that we just apply only 2 voltages, that is gate terminal voltage and the drain terminal voltage. Gate terminal voltage is always applied to enhance the channel, because in depletion mode we doesn't need any gate terminal voltage to create the current or to get the current. Okay. So the drain terminal voltage is positive because drain terminal voltage will decide the magnitude of current, that is ID. Okay. So we just don't care about source and the body terminal. We just care about the gate and the drain terminal. And we understood that this gate terminal is attached to positive. So what is the voltage that must be applied at the gate terminal to enhance the channel? The gate terminal voltage must be greater than the threshold voltage. So if it is like this, then we can say that your MOSFET is working in on condition, because we have created a channel and we can use this channel or the path for the flow of current. So we can say this is on, and if the gate terminal voltage is less than less than threshold voltage, just I want to say, then this is working in off condition. So here we don't have to think about whether depletion layer is formed or not, anything else. We just want to create a channel, or we just want to deplete the channel. Sir, we are not depleting the channel because always we are creating the channel. No, we can deplete the channel whenever we are having already present or physical construction of the channel. So, deplete the channel means we are reducing the width of the channel. So, similar thing, we just take the NMOS similar one, and if I say that this is in a depletion, this is a depletion type, if I say initially, or you can observe initially by watching that whether physical channel is available or not, then again I want to say here that we just don't think about the source terminal voltage and the body terminal voltage, but we have to think about the gate terminal voltage. Now tell me, what is your choice of the polarity to apply at the gate terminal? Sir, I want to apply a positive voltage at the gate terminal in depletion mode. So, if I say that if you want to apply a positive potential at the gate terminal, okay, without applying any potential at the gate terminal also, we can get the current. But in addition to this one, we can apply the gate terminal voltage here positive, or we can apply the gate terminal voltage here negative. If you apply a positive potential at the gate terminal, this positive potential will attract the electrons. That means the negative charge in a physically constructed channel can be increased. That means the conductivity can be enhanced more. Apart from what is the conductivity present initially due to the presence of physical channel without applying any gate terminal voltage. So we can apply a positive voltage in the depletion type MOSFET. So whenever we are applying a positive voltage in the depletion type MOSFET, then I can say this depletion type MOSFET can be used as working in enhancement mode of operation. Can be used as working in enhancement mode of operation. Okay. And now we can choose another gate voltage for this one. Sir, I want to apply the gate terminal voltage is negative. So if you apply a gate terminal voltage negative, then what will happen? The already present electrons in this semiconductor will repel down. The already present electrons that is present in the semiconductor will repel down. If the electrons are repelling down, then we can say that we are not having the conductivity of the channel that was present initially. That means we are depleting or reducing the conductivity of the channel. So when we apply a negative voltage in depletion type MOSFET, this all things can be worked in a depletion type MOSFET, because in enhancement type MOSFET, in which we don't have the channel, we always need to create the channel. This is our main aim for enhancement type MOSFET. But in depletion type MOSFET, we can use either in enhancement mode or we can use either in depletion mode both. So this is one advantage of depletion type MOSFET. So we can use this one in depletion mode of operation. Depletion mode of operation. So depletion type MOSFET can be used in both modes. Either we can apply a positive voltage to attract more number of electrons to increase the conductivity, that means we are enhancing the conductivity, or we can reduce the conductivity, or we can say, so many times we can say that depletion type MOSFET can be worked in both mode, that is depletion enhancement mode of operation. It can work. But if you are talking about an NMOS and if you say that this is an enhancement type MOSFET, then it will never work in depletion mode. It will never work in depletion mode. Okay, so depletion type MOSFET can work either in both. So the gate terminal voltage must be applied. And if someone asked you, sir, either we are working in this or that, we need to have a current, and current means this current. So the drain terminal must be positive here. The drain terminal must be positive. So there is only minute changes that can be seen in enhancement and depletion type MOSFET. So this is enhancement type MOSFET and this is depletion type MOSFET. And we have observed that there is very minute changes that may be seen in this particular two types of MOSFET. So this lecture series is meant for that one only, and I just ask you one quiz question that I felt that this was being asked in a previous lecture also. The channel current is reduced on application of more positive voltage to the gate of the depletion mode in N-channel MOSFET. So channel current is reduced. So that means we are reducing the channel current, and I told you that if you are talking about an N-channel MOSFET, then the channel current cannot be reduced in enhancement type MOSFET, because the channel current always increases because we are enhancing the channel. But if you are talking about depletion mode, then we can increase the magnitude of current and we can decrease the magnitude of current. So if you want to increase the magnitude of current, and we know that this is an N channel, so that means we have to apply a gate terminal voltage which will repel or attract. It must attract because we want to increase the current. So if you want to attract the electrons for an N channel, that means we have to apply a positive voltage. And if it is having a similar channel, then we have to apply the gate terminal voltage to decrease the channel and to decrease the magnitude of current. If the conductivity of the channel is decreasing, that means we are decreasing the magnitude of current, we must apply a negative voltage. Now, understood, what is the question? The channel current is reduced to the application of more positive voltage at the gate of the depletion mode N-channel MOSFET. So if you apply a more positive voltage at the gate, the magnitude of current increases, and we must want to increase the decrease or reduce the magnitude of current. Then I can say that this statement is actually false, which is not correct. Why this statement is false? Because if you want to reduce the current, then you must apply a negative voltage at the gate terminal. And if you are applying a positive voltage at the gate terminal, this will not reduce the magnitude of current. So in proper sequence, if you write from this question that current has to be reduced, and for reducing the current, we are applying a positive voltage at the gate terminal, and we have selected the NMOS in which the substrate is of P-type, N-MOSFET, and then we can say that this is wrong statement. What is the right statement? The gate terminal voltage must be negative if you want to decrease the magnitude of current. So this is one question that was asked in by IIT Roorkee. This is not made by me. This is a quiz question. And in the previous session, or we can see if you analyze the previous year questions of gate, we are having some questions before 90s of gate which is of this type. So this is IIT Roorkee questions, and we just have analyzed in proper way that what is the meaning of depletion and enhancement type MOSFET. So I mean to say that we just have some more questions like this, and we can solve this question. For an NMOS transistor, which of the following statement is true? The substrate is of P-type. We just analyzed that the substrate is actually of P-type in an NMOS, and we have seen this part in our previous session that like this. So we have created some parts here. So substrate is of P-type. In case of NMOS, I have written. The inversion layer or induced channel is of N-type. Yes, this is correct that the inversion layer or induced channel is of N-type because it is an NMOS. So we have to create a channel which is of electrons, that means it is of N-type. And next is the threshold voltage is negative. So if he is asking that threshold voltage is negative or positive, then we have to just understood that depletion type and enhancement type MOSFET, they are two different type of MOSFET. In general, I mean to say that this question is from enhancement type because whenever nothing is mentioned in the question, whether it is in depletion mode or not, then we by default taking the question is of enhancement mode MOSFET. So if you take this is an enhancement type MOSFET, then if you are talking about threshold voltage is negative, this is wrong because in NMOS the threshold voltage that we have written here, the threshold voltage must be that is applied at the gate terminal. Since the gate terminal voltage is positive and the threshold voltage that must be applied at the gate terminal must be greater, gate voltage that is applied at the gate terminal that must be greater than threshold voltage, so that we can create an inversion layer or sufficient number of electrons. So we have already written that the gate is positive, that's why this particular negative has to be omitted from here. But if you go deep inside this one, we have some more answers here. I will demonstrate you. But right now we are having the substrate is positive, the inversion layer or induced channel is N-type. The source and the drain terminal can be interchanged. This is already I told you that in a MOS we can interchange the source and the drain terminal because there is no change in the doping levels of the source and drain. Only the terminals has named like this. You can interchange this one as a source, this one as a drain. So this particular device is also called symmetric device because we can interchange the terminals. Now we are going to analyze the threshold voltage. So threshold voltage is negative. Why it is written here? I mean to say here in a depletion type and enhancement type MOSFET, we are just analyzed here. Enhancement type MOSFET, that means if you are talking about NMOS, I just take an NMOS as an example to understand that what is the threshold voltage. And this NMOS can be written in two types, either it is in enhancement type or it is in depletion type. In enhancement type, initially we don't have the channel, we have to create the channel. So after creating the channel only we can get the current. So first thing is that here step by step, so we have to create a channel, and after creating the channel, as the second thing is that we have to find out the current. Okay, we are getting the current that is not equal to 0. So but the first step is to create the channel. But in depletion type MOSFET, if you won't create the channel, then also we can get a current that is ID is not equal to 0. That means a non-zero value of current can be available. Only the thing is that we have to apply a drain terminal voltage which is positive, or we can say that the drain terminal voltage with respect to source terminal is positive. Here also we can get the non-zero value of current by applying the drain terminal voltage which is a positive or non-zero. So here also we can apply. But what is the difference between these two? The difference between these two is that here we have to create the channel. Here we don't have to create the channel. Without creating the channel, because physically the channel is available, we can get the current by applying a drain terminal voltage. But if you apply a drain terminal voltage directly without creating the channel in enhancement mode, we don't get a current. So that means we can say that this is a normally off device. This is a normally, we can say normally off device, and we have to create a channel. That means we have to make the channel conductive. That means we have to make this device on, then only we can create the current. But here we can directly get the current. That means we can say this is a device which we can say this is normally on device. Okay. So this is on device. So what is the main task that we have to do, sir, here? Only we have to apply a voltage at the drain terminal to get the current. That's it. No. Here we can do some more things. What is those things? We can enhance or we can deplete. Since it is a depletion mode MOSFET, so in general, the use of this one is to deplete or reduce the conductive path. So the second thing that we can use here, apply a gate terminal voltage to deplete the channel. This is the main purpose of creating this. Of course, we know that the depletion type MOSFET can also work in enhancement mode, but already if you have an enhancement mode, we don't want to think that this is again used in enhancement mode of operation. But we can use here. So we have to apply a gate terminal voltage in depletion type MOSFET so that the channel is reduced, so that we can reduce the width of the channel or conductivity of the channel by rippling the electrons downward. So Vg must be applied for the depletion action. So now I want to ask you, in NMOS, what is the voltage that must be applied at the gate terminal to deplete? So we have the reason that the gate terminal voltage must be a negative value, must have a negative value. So that means if someone asks you that in enhancement mode, if you are applying the gate terminal voltage positive, in enhancement mode, we must have to apply a gate terminal positive. And by using this gate terminal voltage, we are applying a certain amount of voltage that is nothing but a threshold voltage. This is applied at the gate terminal voltage and this is a positive voltage. and at this condition we are able to create the channel. So that means the threshold voltage must be positive. But we have to work as a depletion action here, or depletion mode of operation, and we have to apply a gate. And since it is a normally on device, we have to take care that we can be able to off the device. This is the controlling action. So on should be off, or off device should be on. So we are creating a channel, then we are applying a gate terminal voltage. That means all this action will make this device on. And it is already on. We have to apply certain voltage to make this device off. So we can say that we have to apply a gate terminal voltage with certain value of threshold voltage, but this voltage must be a negative. So we have to apply a certain amount of voltage at the gate terminal so that it will be a negative voltage, and to make the magnitude of current, that is ID, is equal to 0. So this in this we want ID not equal to 0. In this we want ID is equal to 0. So if you observe these two things, that the threshold voltage is positive here, the main thing is here, and the threshold voltage is negative here. I must give you a demonstration of this one. Already we have a channel, and if you apply a negative voltage here, we don't apply a positive voltage because we have to deplete the channel. We must apply a negative voltage. Negative voltage will repel the electrons. We are reducing the width of the channel because we are repelling the electrons, and conductivity is reduced. Now we can see that there is no conductive path, and if you apply a drain terminal voltage at this particular condition also, VD, then also we don't have a current. When we apply a gate terminal voltage, a negative value, and this negativity is reducing the conductivity of the channel, and at a certain value of the gate voltage, which is a negative voltage, we are getting the magnitude of ID current is equal to 0. If you apply the drain terminal voltage also, that means we can say the threshold voltage is negative in case of depletion type MOSFET. That's why I am underlining this one. The threshold voltage is negative. So if someone understood that this is a depletion type MOSFET, then they must agree that the threshold voltage must be negative. But we are in general having the question in enhancement type MOSFET until unless it is not said that this is a depletion type MOSFET. In that sense, we can say that this particular answer is wrong. So in this MSQ, we can say that only A, B, C option is correct. But if they mention that this is a depletion type MOSFET, then we must have to take care that the voltage is a depletion type MOSFET. Then we must have to take care that the threshold voltage is negative. This is also correct. So this depletion type MOSFET, if mentioned, then we can say that this is correct. So this is an overall view of classification of the MOSFET, enhancement type or depletion type. We have solved 2 MSQs. We have seen 1 quizzes, and we understood so much concepts about the depletion enhancement type MOSFET. Because this is a crash course, I don't spare so much time in understanding the depletion and enhancement type MOSFET. So you can think that this is the last session of enhancement type and depletion type MOSFET, the differentiation. So in the next session, whenever I come, I will take only the enhancement type MOSFET, because the 90 to 95 question is based on enhancement type MOSFET. So see you again in the next session. So goodbye.